example, whenever we have the digital signatures, uh, what is the definition of a digital signature? A digital signature is an electronic encrypted stamp that verifies the authenticity of digital informations. So here we have many forms of, like whenever we have some business and we have like to send some messages, so we have to have the digital signatures that has been exchanged from any third party too. So for example, suppose that John sends an authenticated message to Mary using one of the schemes, like consider the following disputes that would arise. Like Mary may forge a different message and claim that it came from John. And Mary would simply have to create a message and append an authentication code using the key that John and Mary share. Can deny sending the message because it is possible for Mary to forge a message. There is no way to prove that John did in fact send the message. Both the scenarios are of legitimate concern. Here is an example of the first scenario. An electronic fund transfer takes place and the receiver increases the amount of funds transferred and claims that the larger amount had arrived from the sender. An example of second scenario is that an electronic mail message contains instructions to a stock broker for a transactions that subsequently turns out very badly. The sender pretends that the message was never sent. In situations where there is a not complete trust between sender and receiver, something more than authentication is needed. The most attractive solution to this problem is the digital signature. The digital signature must have the following properties, like it must verify the author and the date and time of the signature. It must authenticate the contents at the time of signature. It must be verified by third parties to resolve disputes. Thus, the digital signature function includes the authentication. Attacks and forgeries. The following types of attack in order of increasing severity. Here, A denotes the user whose signature method is being attacked, and C denotes the attacker. So here, key only attack, that is C, and non-message attack, that is C is given access to a set of messages and their signatures. Generic chosen message attack. C chooses a list of messages before attempting to break A's signature scheme independent of A's public key. C then obtains from A valid signatures for the chosen messages. The attack is generic because it does not depend on A's public key, and the same attack is used against everyone. Directed chosen message attack. It is similar to generic attack except that the list of messages to be signed is chosen after C knows A's public key but before any signatures are seen. Adaptive chosen message attack. C is allowed to use A as an oracle. This means that C may request from A signatures of message that depends on previously obtained message signature pass. An outcome in which C can do any of the following with a non-negligible probability. It is total break, universal forgery, selective forgery, existential forgery. So next is about digital signature requirement. So in order to have digital signatures, what all requirement is needed? So the signature must be a bit pattern that depends on the message being signed. Signature must use some informations only known to the sender to prevent both forgery and denial. It must be relatively easy to produce a digital signature. That is, it must be relatively easy to recognize and verify the digital signature. It must be computationally infeasible to forge a digital signature either by constructing a new message for existing digital signatures or by constructing a fraudulent digital signatures for a given message. It must be practical to retain a copy of digital signatures in storage. Direct digital signatures. The term direct digital signatures refers to digital signature scheme that involves only the communicating parties. It is assumed that the destination knows the public key of the source. Confidentiality can be provided by encrypting the entire message plus signature with a shared secret key. Note that it is very important to perform the signature function first and then an outer confidentiality function. In case of dispute, some third party must view the message and its signature. If the signature is calculated on an encrypted message, Then the third party also needs access to decryption key to read the original message. However, if the signature is an inner operation, then the recipient can store the plain text message and its signature for later use in dispute resolution. So whatever, whenever, and we have some business deals, so the this signature plays a major role. So the validity of the scheme just described depends on the security of the sender's private key. If a sender later wishes to deny sending a particular message, the sender can claim that the private key was lost or stolen and that someone else forged his or her signature. Administrative controls relating to the security of private keys can be employed to, or at least we can deploy, but the threat is still there at least to some degree. So one example we can say that it includes a timestamp and to require the prompt reporting of compromised keys to a central authority. Another threat is that a private key might actually be stolen from X at time T. The opponent can then send a message signed with X signature and stamped with the time before or equal to T. The universally accepted technique for dealing with these threats is the use of digital certificate and certificate authorities. Digital signature standard. So it is one of the federal information processing standard, that is FIPS, which defines some algorithms that are used to generate digital signatures with help of secure hash algorithm for authentication of electronic documents. So here we have a diagram where the sender sends message to the receiver, and the hash functions and the signature functions is being the combination of encrypting the particular message, and then along with that hash code and signature function is being sent to the receiver. The receiver verifies whether that particular uh, compares that particular hash code and signature is being same. So the sender side, the hash code and private key of the sender, the global key, which is a set of parameters for communicating the principles. And the input to the functions will provide us with the output signatures, which is containing the two components, that is SNR, sender and receiver. So the same thing vice versa with the receiver side also, we need the same thing, that is being the hash code, the signature components, the public key and the global key. The benefit of advanced signature is the computerized signatures gives better security in the exchange. So it gives a high velocity, and it is undoubtedly it has been following the situation with the archives on which the computerized mark is applied. It is 100% lawful and it is given by the public authority. It is approved ensuring authority. In the event that you have marked a report carefully, you can't deny it. In this mark, when a record is get marked date and time or consequently stepped on it, it is preposterous and to expect to duplicate or change the report marked carefully. Idea of the individual that signs disposal of the chance of committing misrepresentation and burdens of computerized signature. You really want to investigate all the similarity issues, and if there are a great deal of similarity settings like refreshed renditions of a driver in programming. It is one of the main pressing concerns while utilizing a computerized signature testament. So, e-tagging and all that is very necessary, and there are some MCQs that you can go through and answers are given. Thank you.